heat tape on and heat that flow or heat that material up to where it flows nice and smooth. If that heat trace goes bad, they may have to pull the insulation off and everything, redo the heat trace to where it's maintaining at least a 60, 65, or 70 degree temperature in order to flow correctly. Okay? Just something to keep in mind. Most systems in the Rocky Mountain region are typically insulated and heat traced because of our winter cycle. You know, maybe in Texas, Georgia, and so forth, they don't see that cold temperatures during the winter time. They won't have to insulate or heat trace it as much. But on the other hand, they're going to see an extreme spike on the high side to where they may want to keep it insulated so that it keeps the heat off of the metal itself to keep it from increasing on like gas pressure or so forth. Okay. Weight, we talked about this. Pipe with thinner walls can be used. Appearance, space. Threaded system, a system of full range of pipe sizes 2 to 6 inches. And 6 is pretty hard. Typically, if you get above 2-inch material, you're no longer going to be hand threading it. You're going to have a physical, a really big piece of equipment that you're going to need to be able to cut the threads in that material. It takes a long time. You may have to do it in 2 or 3 steps, stepping your die down a little at a time, and then if you make a little mistake, then you can booger up the threads, throw it away, cut it, add a new putt piece or something like that. So anything, most pipe specifically above 3 inches and beyond is almost all welded pipe. All right. Pipe specifications. Specs for ferrous and non-ferrous pipe. Again, ferrous means it contains iron. Non-ferrous, it does not contain iron. All right. The American Society for Testing Materials, the API. API is specific to cross-country pipelines. However, there are many places that fall underneath the API 1104 code as well. Again, we don't have a ton of pipelines in Oregon. However, we have a lot of refineries. So, it's Petroleum Institute, correct? So some of the refineries, even though it may not be going across a cross-country cargo pipeline system, the trucks may be hauling it in, you know, crude oil or anything, and from that point they might be producing and mixing the blends that they want, so forth. That would fall underneath the API code as well. Okay. Table 16.2 lists standard pipe sizes. Table 16.2 is on page 487. This is your nominal wall thickness for schedules, including pipe size, so forth. Now I want you to take a really good look at the pipe schedule. You should understand it very well. I'm going to pull the camera off here and we'll talk about it. Well, let me make sure it's not on a slide. Nope. So, let's take a gander real quick. So when we talk about pipe, we're going to look at the nominal pipe size. Okay, so let's go down to a 2-inch. So we're going to call it 2-inch pipe, but it's not exactly 2 inches 100%. So the outside diameter is 2.375, 2 3/8 of an inch. Now let's go over here and let's look at the schedule. So the schedule 40, the wall thickness is 0.154. Schedule 80, it's 0.218, so thicker yet. We get all the way over here to 160, and, sorry, I lost my spot here. 2-inch. And we're at 0.343. Real quick, 6-inch nominal pipe size right here. Our outside diameter is 6.625, so 6 5/8 pipe. Schedule 40.280 wall, 432 wall on our schedule 80. And then we get all the way over here to schedule 160, and look at that, 0.718. That's almost 3/4 of an inch per side. Something to understand real quick, 12-inch nominal pipe, the outside diameter is 12.75. Now look right here. Once we get to 14, it's outside diameter. Our nominal pipe size becomes the exact same distance as our OD from there on out, okay? So at 12 inches, above 12 inches, the outside diameter is the same as the nominal. Schedule 40 doesn't have, okay. Just something to keep in mind. You should be aware of the pipe schedules, wall thickness. That is how welding codes and standards will restrict what you're allowed to weld on as well. Okay. All right, carbon steel pipe. This is the everyday average pipe that we're going to see. You're going to have lower grades and higher grades of pipe. So for example, a sprinkler system. It's not a high pressure system, it's going to be a lower grade of pipe. It's basically a lower quality of pipe as well, okay? It's the most widely used in the material in the piping systems, relatively low cost in order to replace it. If they needed to, it's not that bad or not that expensive. Most welders can usually, if they're welding on a pipe system, a lot of them are going to practice on carbon steel, and that's what they're familiar with. Now, some of them, of course, will be able to do stainless, aluminum, so forth, but it takes more skill level and on, okay? Now, you can get SA 106, so one grade of pipe that's very common that we're going to use here in the shop is an SA 106 grade A or B. Now, grade B, naturally, grade A is the lower quality pipe, so its tensile strength may only get up to 50 or 45,000 pounds PSI, I should say. Grade B is going to get up to, say, 70,000 PSI. So that's where we want to really pay attention to the details of what grade and what quality of material we're using. What is it spec'd for? What's the job spec for? Do we need to preheat? Do we need to post-heat? What type of welding filler metals are we going to put in? All these variables start coming into action when we start looking at what type of materials and so forth, okay? High yield strength pipe. This is again more of a specialty item. So an API X72 versus 52. So this may fall under the same thing as an X52. It's about a 70,000 PSI, so the same as SA 106 grade B material. Different companies have different numbers that they put on it, okay? Or different manufacturers, I should say. High yield strength pipe might be an X72 pipe. So this tensile strength might be up closer to 100,000 pounds per square inch, all right? When we get to that, then we really want to think, well, it's preheated. It needs to be at least 250 degrees minimum before we put our root into it, before we even touch it. What are we going to do? It's going to be more prone to undercut. It's going to be more prone to slag entrapment. It's going to be harder to weld. I'm going to have to physically push in a little more and so forth, all right? Chrome moly pipe. This is where we start to get into, it's got the additions of chrome and molybdenum. So if we're going to do something that might be acidic or carry a lot more heat to it as well, we might be using chrome moly pipe. So for example, gun barrels a lot of times are used where originally the chrome moly material was used on gun barrels. They didn't heat up as quick, they didn't grow as much, so your coefficient thermal of expansion was less. as they heated up, they grew some, but not quite as much as the lower grade steel. All right. Chrome moly pipe has a different grain structure, so it increases height. It's got increased high temperature strength. Advanced temperature limits piping. Excuse me. Some of the drawbacks are chrome steels have a tendency to air harden. So especially on this, we're going to look at a preheat and a post-heat to make sure that we don't create dendrites, our dendrite patterns and so forth, are not creating micro cracks within grain boundaries along the dendrites and so forth, okay? So right here it says controlled annealing may be necessary. So that's where I'm talking about post-heating as well. So you may want to bring it up to 700-800 degrees or higher depending on the procedure. You know, sometimes 1100, 1200 degrees. Hold it there for a specific amount of time to stress relief the weld and the grain structure, and let it come down slowly and nice and cool, and you wrap it up with insulation, or you may be doing it with electric heat blankets on the thermometer, and you may simply be out in the field with a weed burner trying not to heat up one piece and just kind of create an oven furnace effect around the entire thing to bring it down nice and slow. Okay. Chrome nickel or stainless steel pipe. Special considerations given to austenitic stainless steels when they are to be welded. They're hot formed or used for corrosion resistance. Chromium carbides formed along the grain boundaries and reduce corrosion resistance at temperatures from 800 to 1500 degrees. Minimized by addition of small amounts of stabilizing elements, niobium or titanium. So if you went through chapter 3, we've talked about this, and that's in welding 3. We've talked about at certain temperatures the chromium carbides are attracted to the weld puddle. So they leave their home position, and you know, they come to the heat, creating issues along the weld profile. We need to release those or use low carbon material to help minimize it at best. Okay. Low temperature pipe. It's always an ever increasing demand for pipe that can provide satisfactory service at low temperature, various grades of steel pipe. We may see low temperature pipe at you know, it's like to extract helium from different products. We have to get it down to a really low negative, below zero number, okay, 200 or so below zero. So we need something that can handle that cold temperature as well, and it's not going to start cracking and having an issue. Non-ferrous pipe, so it does not contain iron. Used for extreme condition, very high temperatures, corrosive conditions, beyond abilities of ferrous metals. Most common non-ferrous pipe materials: nickel, copper, titanium, and aluminum. Okay. Right here, nickel alone has very good low temperature properties, and also high temperature properties. Okay. There's some different alloying elements you can add with nickel, like a Monel, Inconel, to give it really good high temperature properties, but nickel alone, very low temperature properties. They hold well. A good example is a lot of fan blades or turbines on airplanes can be made of nickel, because the coefficient thermal expansions, they don't shrink as much. So if you're up there on an airplane and you go from 30 degrees outside to that high in the air and it gets sub-zero, the last thing you want it to do is to shrink up and fall off while you're in the middle of the air. Okay, so the engineers have used the right material, the right fittings and everything to keep it on there. Okay, it's been designed for a reason to use that certain material. Okay, so there's some alloyed compositions: Monel, Inconel, Hastelloy, red brass, yellow brass, and Dupper nickel. I've never dealt with Dupper nickel or Hastelloy, but I've dealt quite a bit with Monel, Inconel, red brass, yellow brass, so forth. Inconel, a lot of times you're going to see, these two you'll see in high temperature systems, flare stacks, high pressure piping on steam systems. It's going to see high temperature and high pressure. All right. Okay, shielded metal arc welding, one of the principal processes for welding pipe. Welds of X-ray quality produced, may be used for nearly all ferrous and non-ferrous piping. Standard welding power sources may be used, alternating or direct current. The most common one by far is the direct current. Wide range of electrode types and sizes available. Welding is done in all positions, vertical progression, direction up or down. So again, remember, vertical weld is all in the same plane. It means that it is going, the weld axis is going vertical, okay? The progression is whether you're welding uphill progression or downhill progression. It does not matter. Most typical pipeline systems for 1104 code are primarily downhill. However, thinner wall pipe, so forth, it's faster, less distortion, less warpage. Uphill systems on typically for ASME code, B31.1, B31.3, whether it be process piping or pressure piping, those are typically your uphill welds, okay? One of the reasons they use mainly low hydrogen electrodes because they're seeing, they're trying to match that higher tensile strength as well as less slag, entrapment, porosity, and less growth within the grain boundary as well, okay? Real quick, let's talk about just one other principal example of this for shielded metal arc welding is you do not, it can be used in any application. So if you're outside and you don't have what we call welding hooch to where you can put over top of it, kind of block the wind off and so forth, you can use it outside within the elements of wind, a little bit of rain and so forth. You want to block it off for some rain, but it's a lot more friendly in the elements than it is if you were just doing gas metal arc welding. They both can produce a good weld, but gas metal arc welding, you have to be very careful about how much wind you have, your shielding gas, so forth as well, all right? Cooling rate of your pipe and so forth. Pipe welding electrodes, E6010 classification, what we weld in the shop, 6010 5P, designed to penetrate. Tensile strength of 50 to 65,000, 60,000 minimum. I do not like the way this is read, or this is wrote on this PowerPoint. Remember, we follow the electrode designation. If it says 6010, the first two numbers are your tensile strength, so a minimum of 60,000, okay? Some manufacturers make two types. It's designed especially for pipe and open joint penetration welds. For an open weld mainly, okay? Again, not every weld you're going to do is going to be an open weld. However, we're going to teach you to do both, okay? We're building your personal toolbox and your ability to go out there and sell yourself and be a successful welder. If you can do an open root weld, usually the closed root welds or partial joint penetration are a lot easier to do because it's 70-18, you're doing the same thing. But you have to know how to do the open root welds as well, okay? E6010, very similar to, or 6011 I mean, is very similar to 6010. It's used with alternating current. You'll see this a lot in shops that do not have all the capabilities of welding just a DC welding or a direct current welding machine. You know, this is kind of the old school, what we used to call a ranch rod. It holds together fine, works well. You can usually go down and buy a $300 to $400 or $500 welder and on an alternating current, and it'll weld just as good as, it'll hold just as well as a 6010 for most of what we're doing around the ranch, small fabrication shops and so forth that may not be held to a quality product. All right? Can be used on DC, but it loses many of its characteristics. (70-10), higher tensile strength naturally. Same thing, you can read through this on your own. Pipe welding electrode, 70-18, 90-18G, and 110-18G. Okay? We'll get into the G here in a minute. Low hydrogen electrodes, because they end in 8. Used to weld high tensile and low alloy pipe, so the higher the pipe tensile strength, the higher the designation. So 70, 65 to 80, 90, and 110, 115,000 psi. Okay? Most common types is a circumferential butt joint, groove weld, or a socket weld. Okay? So typically they're going to go all the way around the pipe, around the circumference of the pipe. The butt joint is where you have two pieces together, put them here, and you fill the gap in between. The socket weld type is where you have a flange or a valve that is there. I'll go ahead and do an example. So here is the circumferential butt joint here. Two pieces are there, same size, same dimension. Your weld is here. The socket type, your pipe may end here, and then over top of it might be a flange or bolt-up piece. So there's going to be a slight air gap here. Naturally, you cannot get to the interior of the pipe, so you'll be welding here, quite possibly on the inside as well, to keep it from leaking. Okay? Butt joints can be done in an open row situation. They might be set up with an inner line called a backing ring or a chill ring for support, or use no inside support whatsoever. Okay? I'll show you a quick example of that. Okay, so on the top piece there, we have open rut weld. So we put our open rut in first, and then we fill it in. Okay? If we were to have a chill ring or a backing strip on it, most of you have done the backing strip in our shop, but a chill ring is a material that expands, and it might lay just like a backing strip here. It's usually made of some sort of a material that will not bond to the metal. Okay? So when you put this weld in, say it had to be welded with all 70-18 electrodes, you would put a chill ring in, and you would just allow your metal to fuse in right there, and then you would pull